Let's start with a review on the terminology of solving systems of equations. First, what is a system of equations? Two or more equations considered together. In this class, we will deal with only two equations and only systems that have linear equations, straight lines. What does it mean to solve a system of equations? Algebraically and graphically. Algebraically, that means with the equations. Algebraically, you're finding an x and a y that make both of your equations true. Graphically, on a graph, if you graph both of your lines, you're finding the coordinates of the intersection point. That's the only point that's on both lines. What will the answer look like? Your answer will be an ordered pair. It'll be the xy coordinate of that point that's on both lines and the xy that make both equations true. We have already talked about graphing method and substitution method in order to solve systems of equations. In this module, we will learn the addition method. Let's review how to solve a system using the graphing method. Here's our system. When lines are in standard form, as these are, they're harder to graph. So we're going to change them into slope-intercept form. Y equals mx plus b. To make it easier for ourselves to graph. Now I can graph. I know my y-intercept is 3, the b number, and my m number will give me my slope, or my pattern. Down 3, right 2. Down 3, right 2. And we'll do the same thing with our other equation. Subtract 5x from both sides. Again, I'm changing into slope-intercept form so that it's easier for me to graph. Divide every term by 2 to get y by itself. Y equals mx plus b. My b number is 1, which corresponds with my y-intercept. And I will go down 5, right 2. And we're not going to intersect down there, so let's go backwards with our pattern. Up 5, left 2. There's our intersection point. So now to get our answer, we want the x and y coordinates of that intersection point, the only point that's on both lines. So our x coordinate is -2, y coordinate is 6. Now we'll review the substitution method. First step in the substitution method is get an x equals or y equals equation. I'm going to use this equation, and since the coefficient of this is 1, this y, I'm going to solve for that y. Be careful of that negative that's there. This is negative y. Got to get rid of that negative before I start. To get rid of that, I'll just divide every term by -1. That'll make this y equals 2x minus 5. Step 2, do your substitution. We know that y is equal to this stuff. So now go to your other equation, the one you haven't used yet, and substitute that stuff in instead of the y. So step 2, I'm going to rewrite that top equation without the y in it. I'll put parentheses instead. And then I know that this stuff is equal to y. So I put the y stuff in place of the y. Now I have an equation that has only one variable in it. So now I should be able to solve. Step 3, just solve that equation. Use our algebra to solve. So distribute. Add like terms. And solve for x. Undo what's been done to the x. Okay, I'm half done. I know that x equals 2. So now take one of your original equations. You can use either of your first original equations or the one you made. In substitution, I like to use the one I made. I sometimes even do this step in my head. I know that x is equal to 2, so I replace the x with a 2. So now I found y. Y is -1. So my very last step, step 5, is to write this as an ordered pair. The x-coordinate is 2, the y-coordinate is -1. There's my answer. That should make, that x and y will make both equations true if I sub it back in.